Hi everyone, today we are in lesson 14, and lesson 14 is solving real-world problems that involve area of figures with fractional side lengths. So I took a look at lesson 14 Zern, and in that lesson, the Zern lesson is question 1. So I'm not going to work on question 1 with you today, but I will tell you that if you haven't Zerned that lesson yet, you need to know how to add fractions, you need to know how to subtract fractions, you need to know how to make like units. So again, if you're struggling in those areas, Khan Academy is a great resource to help refresh those skills. You can Google it at khanacademy.com, or it might be khanacademy.org, but I think it's khanacademy.com. And then you can search for whatever you're trying to refresh, whether it's adding fractions, subtracting fractions. So we're actually going to start in question 2. Joe uses square tiles, some of which he cuts in half to make the figure below. If each square tile has a side length of 2.5 inches, what is the total area of the figure? So when we start this problem, I want to identify our question. What is the total area of the figure? And that question is going to help create our statement. The total area is, and I know we're working in inches, so it's going to be inches squared because I'm working in area. Area is always squared. Okay, so before we start, we have to take a look at this figure. So in the problem, it told us he's using square tiles. So here's what I know about anything that is square. All the sides are the same length. So when it tells me in sentence 2 that each square tile has a side length of 2.5 inches, I know that no matter what square I'm looking at, 2.5. So all of these side lengths are going to be 2.5, and we're going to need that in a minute. Okay. So I have to come over, look at my picture, and I see a couple of things. One, I see some whole tiles, and that's going to be easy for us to figure out how many tiles do we have, because we need to figure out how many tiles is Joe using before we can figure out total area. Okay, so we're going to do that first. So I'm going to start with my whole tiles, and I'm going to mark them with a highlighter. So I have 1, 2, 3, 4, 5, 6, 7. Okay, so I have 7 whole tiles. I'm going to write that over here because I want to keep track of my tiles. And then I see that I have these half tiles. I would hope that you would see that we could take this tile and we could technically add it to this one, and that would complete and make one whole tile. So we're going to have one whole tile here. If we took this tile and moved it up here, we would have a whole tile there. And if we took this tile and moved it over here, we would have one whole tile. Okay, now as I did that, Miss Ponte just realized we have more than 7 whole tiles. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Mrs. Ponte makes these videos early in the morning. Okay, so we have 10 whole tiles that we could see, and we have 1, 2, 3, 4, 5. We have 6 halves, which we just realized that 6 halves equals 3 whole tiles. So when we think of how many tiles do we have all together, we're going to have the 3 whole tiles plus the 10 whole tiles. So we have 13 tiles total. Okay, that's the first bit of information we need. Now, we have to determine the area of the figure. So we have to figure out the area of one tile. So we're going to take this 2.5 inches and we're going to multiply it by itself. So area of one tile is going to be 2.5 times 2.5. And I'm going to use the distributive property to figure this out. So I'm going to start over here. I'm going to multiply 2 times 2. And then I'm going to multiply 1/2 times 2. So we did 2 times 2, and we did 1/2 times 2. Now I'm going to multiply 2 times 1/2, and then 1/2 times 1/2. So I know that 2 times 2 is 4. 1/2 of 2 is 1. 2 times 1/2, we just did that, so that's another 1. And then 1/2 times 1/2 is 1/4. So that's going to equal 4, 5, 6, and 1/4 inches squared. So this is the area, again, of one tile. But we know we have 13 tiles. So in order to find our total area of this figure here, we're going to take our total number of tiles and we're going to multiply that by the area of one tile, because that's going to tell us essentially how many we're using total. So 13 times 6 and 1/4 inches squared. I'm going to use the distributive property once more. So I'm going to do 13 times 6 plus 13 times 1/4. Okay, 13 times 6, don't know that in my head. I'm going to come up here. 13 times 6. 6 times 3 is 18. We're going to bring over our 1. 6 times 1 is 6, plus 1 is 7. So we have 78 plus 13/4. We can't leave 13/4 like this, so we have to take our fraction greater than 1 and make it into a mixed number. I know that 4 goes into 13 3 times. 4 times 3 is 12. So we're going to subtract that 12 from our 13, and that's going to leave us with 1/4. So now we are adding 78 plus 3 1/4, which is going to give us a total of 81 1/4 inches squared. So when we go back up to our answer, the total area is 81 1/4 square inches. Okay, so you can see in that problem alone, we had to have an understanding of 2 halves making 1 whole. We had to be able to multiply our fractions. We needed to be able to add fractions. We needed to be able to take fractions greater than 1 and put them in mixed number form. So a lot of those skills that we learned in modules 3 and 4 are coming back to us in module 5. Okay, so we're going to do one more. Question 3. All-in-One Carpets is installing carpeting in 3 rooms. How many square feet of carpet are needed to carpet all 3 rooms? Okay, so we're going to start with our question. We're going to underline it. How many square feet of carpet are needed to carpet all 3 rooms? And I can see from my word problem, that's all the information they give me. So I'm going to make my answer statement. Let's see. Blank square I just wrote square twice. Blank square feet is needed to carpet all 3 rooms. Okay, so if we come over to our picture, we can see that we have 3 rooms: room A, room B, and room C. And I want to identify what information I've been given. So I'm going to start with room A. Now, I know that to find area, I need to know the length and the width of each room. So room A, I can see that my length is 25 1/4 feet. I can also see that my width is 15 1/2 feet. So I have the information I need to find the area of room A. So I'm going to come over to room B. I can see that the length is 18 1/2 feet and the width is 19 feet. I have everything I need to find the area of room B. When I get to room C, I'm noticing, they haven't given me the length like they did in the other problems. They've given me the width, 16 3/4 feet, but they haven't given me the length. Now, what I would hope you would start to observe in this problem is that they have told me that, let's see, this space between the left side of room A and to the first side of room C, well, that's 2 feet. And then there's another little space that equals 2 1/4 feet. So we're trying to solve for length, which is this right here, from here to here. Now, if I was to move room C over, so that way it was flush and aligned with room A, then that would help me see that, okay, well, room C is this much less than room A. So we need to take this information, the 2 feet and the 2 1/4 feet. If we subtract these from our 25 1/4 feet, we will get the length of room C. Okay, and I kind of want to, if this is room A, I want to give you this visual. So this is room A. And if room C, instead of being, offset, if room C was like this, then we could see that the length of room C is minus this right here. Okay, so we could take our total length and subtract this part that we're given, and then we could find the length. So we're going to do that. So I'm going to take 2 feet and multiply it by 2 1/4 feet. I'm going to do that over here. So we have 2 feet times 2 1/4. Okay, and I'm going to do this in my head, you guys, because this is using some small numbers, so I think I can do this. So using the distributive property, 2 times 2 is 4, and I'm going to add that to 2 times 1/4. So 2 times 1/4 is 2 times 1 is 2, and it's over 4th. Okay. Is that right? That's right. Yeah, that should be, what is that? 4 2/4? Is that what that is? I'm feeling like it is. I'm just double checking something real quick. Oh my gosh, you guys, Mrs. Ponte is going nuts right now. That's not multiplication. I'm just adding those two things together. That's why I thought my math looked a little odd. Okay, so I have to add these two together. I'm going to add them together and then subtract. So 2 plus 2 is, this is going to equal 4 1/4. And then I'm going to subtract this from my total length of room A. Okay, so that's going to look like this, 25 1/4 minus 4 1/4. 25 minus 4 is going to equal 21. 1/4 minus 1/4, well, those just cancel each other out, right? So we now know that the length of room C is 21 feet. So now we have all of the information we need to solve all of these problems. And I honestly don't think I'm going to have enough room. So I'm going to grab a piece of paper to solve. Okay, so I'm going to kind of shift for a minute. I'm going to move this up. Okay, so I'm going to start with room A. Once I get everything written out, I will move this paper up. So you might not be able to see me. So room A is 25¼ feet times 15½ feet. Let's see. I'm going to move this over. Okay, so I'm going to start solving for room A. So using the distributive property, or you could use an area model even. So you might want to solve like this. 25 plus 1/4. And then this is 15 plus 1/2. So maybe that's how you want to solve, which that's fine too. However you want to solve, whatever strategy works for you. I'm going to use the distributive property. So we're going to end up with 25 times 15 plus 1/4 times 15 plus 25 times 1/2 plus 1/4 times 1/2. Now, just to let you guys know, you can always take a break in these videos. So after question 2, you could pause, work on something else, and then come back and watch question 3 if you like, because I know this video is going to be a tad bit longer. So we need to do 25 times 15 first. I'm going to do that work over here. 25 times 15. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. 1 times 5 is 5. 1 times 2 is 2. Okay, we're going to add those. 5, 7, 3. So this is 375 plus 15/4. For right now, I'm going to leave them like this. Plus 25/2 plus 1/8. Okay, so now we need to go and make our fractions that are greater than 1. We need to put those into mixed numbers. So we're still going to have 375. 4 goes into 15 3 times. 4 times 3 is 12. So when we subtract that from the 15, we're left with 3/4. 2 goes into 25 12 times. 12 times 2 is 24. So 24 minus 25, that leaves us with 1/2. And then plus 1/8. Now I have 4ths, halves, and 8ths. I'm going to use 8ths. That's my common denominator. So this is going to become 3 6/8, right? Because 4 times 2 is 8, so 3 times 2 is 6. Plus 12. 2 times 4 is 8, plus 4/8 plus 1/8. Okay, so now we're going to start adding our whole numbers. We have 375 plus 3. That's going to give me 378. And now I need to add 12. So 378 plus this 2 is going to take me to 380. Plus my 10 is going to take me to 390. And I have 6 plus 4 plus 1. So 6 plus 4 is 10, plus 1 is 11. I have 11/8. We can't leave it like this. So we know that 11/8 is going to become 1 3/8. So when we add those together, we get 391 3/8 feet squared. That is room A, just room A. Now you would need to do room B. Room B is 18.5 feet times 19 feet. Thank goodness. This is going to be a little bit simpler for the distributive property. We're doing 18 times 19 plus 1/2 times 19. Okay, 18 times 19. Off to the side. 9 times 8 is 72. 9 times 1 is 9, plus 7 is 16. 1 times 8 is 8. 1 times 1 is 1. Add those together. 2, 14, 342 plus 19 halves is going to end up being 342 plus 2 goes into 19 9 times. 9 times 2 is 18, and so that leaves us with 1/2. 342 plus 9 is going to give us 351. 1/2 feet squared. Okay, room B, done. So let me circle room A, room B. Moving on to room C. So we figured out earlier that room C is 21 feet, and it's going to be times 16 3/4. 21 times 16 plus 21 times 3/4. And do my multiplication off to the side. 6 times 1 is 6. 6 times 2 is 12. 1 times 1 is 1. 1 times 2 is 2. Add 6, 3, 3. So 336 plus 21 times 3. We can do this over to the side if you can't do that in your head. 3 times 1 is 3. 3 times 2 is 6. Plus 63 fourths. Okay, so 4 goes into 63 15 times. 15 times 4 is 60.